In the beginning, there was only energy, which was infinitely dense and very hot. All energy was in a single point, and all forces were unified. Then in 20 minutes, everything changed. Imagine something in your life that took 20 minutes. A walk home, a chapter in a novel, an episode of a show. It can't be argued that these things don't take very long. Same goes for the creation of the entire universe. From nothing to everything, in so short a span of time, all in a big bang. And it takes 365 days for a ball of rock to rotate around a ball of hydrogen. How did that happen? And how do we even know about it? Time and space began in 10 to the power of negative 43 seconds in the Planck era. It's the only time in the Big Bang Theory with an era name designated to it that's kept consistent in what I've read. So, what was the weather like back then? Well, it was only 10 degrees, to the power of 32 in Kelvin units. Kelvin starts measuring temperature at the coldest possible temperature, by the way. Still, a little heated, I would say. This is when matter and antimatter began to form. When particles were created, they were created in these particle and antiparticle pairs. It was also the time when the universe became 10,050 times its previous size. Whenever you believe your accomplishments in life are adequate, see how quickly the universe got things done. The conditions were so over the top that our human understanding of how the universe works can't explain many of the extreme conditions. That understanding is called physics, by the way, and is probably the most interesting science of the boring sciences, and by that, I mean all of them. From 10 to the power of negative 43 to 10 to the power of negative 35 seconds, gravity is separated from the other still unified forces, which honestly is quite sad. Doubt they even said goodbye. So now 10 to the power of negative 35 seconds have passed, and due to the separation of another force, the strong nuclear force, cosmic, that's the universe, inflation, that's the universe getting bigger, has created a quark-gluon plasma, which is made of quarks and gluons. Quarks are tiny subatomic particles without any structure, which make up tiny things with weird names, such as baryons and mesons, and they in turn form things you may know, such as protons and neutrons, but not electrons. Gluons exchange a strong charge between quarks, therefore transferring strong force, the thing that keeps quarks together. Gluons are clearly the carer in the relationship. Anyway, these two things are in a very high energy density in the plasma, and can't be attracted to each other at such levels. When building blocks of the universe are too heated to be with each other, you know the universe would make the sun look like a freeze tank. The whole situation was more of a soup than anything developed, as if it could be called quark soup, or just quark-gluon plasma. This quark soup also gave rise to antimatter, which are just antiquarks and antileptons, and due to one extra quark being made for every billion antiquarks. The normal quarks seem to have won out. Also, meet quarks, or hadrons, who is just made of quarks, brother, named lepton, whose opposite I just mentioned, and has no structure like a quark, and yes, electrons are leptons. The matter winning over antimatter may not seem important to you, but keep in mind, you're made of that matter that was created extra for every billion. So to conclude, lots of expanding and heat still. Now it's 10 to the power of negative 11 seconds, and the two other forces have decided to split up, the weak nuclear force and electromagnetism. Now the forces of the universe have divided, and are the four we know of today. The universe is cooled to what is now 10 to the power of 5 seconds. And guess what quarks and gluons were finally able to do, thanks to gravity? Create protons and neutrons. Keep in mind, it is 10 to the power of 13 degrees Kelvin, so still by human standards it's incomprehensibly hot. It's been only a second now, and the temperature is looking to be 10 to the power of 10 Kelvin. From 1 second to 3 minutes, the quarks and antiquarks have mostly been annihilated. However, leptons, think electrons, and antileptons, think positrons, are prospering, and the annihilation photon energy was freed, and helped make more electron-positron pairs. And finally, from 3 minutes to 20 minutes, atomic nuclei begin to form in the universe, and they're mostly full of leptons and antileptons. The nuclei are just combinations of protons and neutrons, and they combine to create simple elements that may be the first scientific words you recognize from this video, such as hydrogen and helium. This nuclear fission stops at 20 minutes, however, due to the temperature getting lower and density of the universe being too low, but way too high when accounting for our human bodies. And all that was in 20 minutes. In case you didn't notice a pattern, most of the things that occurred happened between 10 to the power of negative 43 and 10 to the power of negative 35 seconds. This rapid expansion was quite rapid, but eventually things settled down, at least where we live, and the temperature did eventually get low enough for things like life and human existence. So that's the human theory on the first 20 minutes of the universe, the first 20 minutes of the Big Bang Theory. But how can this information be applied today? It can be applied to fields of science, most importantly physics. Knowing the beginnings of our physical realm helps us understand why it is the way it is. And scientists can use it to experiment with questions that haven't been answered. Humanity has been around for 3 million years, and the current answer to the universe's creation was only proposed in 1927 by a Belgian priest. We should consider ourselves lucky to be born in such a time, or as a priest would say, blessed. Thanks for watching.